Okay, in section 5.2 called Turn It Up to 11, there's not a lot of new material in this section, but what we're going to do is we're going to make the proofs a little bit harder, and some of the proofs actually get a lot longer. So let's take a look at this first proof here. It talks about circle O, and in circle O, O is the center of the circle, and it's marked that, or it's given that FG is congruent to GH. We oddly enough don't have a triangle here. So what we have to do on these particular problems where it's clear that something's missing, we have to draw in some lines. So we're going to draw in these dotted lines, and these dotted lines are called auxiliary lines. And auxiliary lines, if you look to the bottom of the page, is right here. Okay, and it says that sometimes you'll need to draw it in your diagram in order to solve the proof. And so in this case we drew the radii in there, and the way we'll do this in a proof is we'll say draw FO and HO. And it's going to be 2 points determine a line. And in this case, it's a line segment. And then we know that those radii are congruent to each other, so I can say that FO is congruent to HO, because radii are congruent. Okay, it looks like we're headed towards proving the triangle is congruent. And then it looks like angle FGO is going to be congruent to angle HGO using a CP/CTC. So I got a reflexive down the middle here. GO is congruent to itself. And hopefully you can see that the triangles are congruent by SFS, and then this is going to be by CP/CTC. Okay? I'm not going to write out the rest of that proof. It's a pretty simple proof. The one thing I do want to caution you of is, okay, so in proofs like this where it's clear that, you know, the reason why it's clear that a line's missing is we've been doing congruent triangle proofs for chapter 3 and now in chapter 5. And here it's pretty obvious that there's no congruent triangles. Okay, there's no triangles to prove congruent. So and also it's talking about segment AT, which doesn't exist here. So again, you need to draw in the segment, and then you can continue on with the proof. That said, please don't get carried away with auxiliary lines, okay? Most of the time, unless it's something obvious, most of the time you do not need to draw auxiliary lines, okay? Let's move on to the next page, and we're gonna reintroduce some material and then do some proofs. Okay, just a quick refresher on page 2 here of altitudes, medians, and bisectors. An altitude is basically going to give, it's going to be drawn from a vertex perpendicular to the opposite side, so it's going to give you perpendicular lines, or I know that in our book it allows you to say it gives you right angles. Medians are drawn from a vertex to the midpoint of the opposite side. So you can say median's going to give you a midpoint or 2 congruent segments. And then bisectors. There's going to be angle bisectors, which will give you 2 congruent angles, as it chops a single angle into 2 congruent angles, and a segment bisector, which is going to give you 2 congruent segments. Okay, and so we're going to use this in some proofs. The first proof here is an example of this. So it says that AT is an altitude drawn for this triangle AMN. So we know that it's going to give you perpendicular here, or 2 right angles. AT bisects an AM, so that gives you these 2 angles congruent right there. And then it says find that it's a median. And for a median, we know that we need congruent segments. And in particular, I need MT congruent to TN. So I think I can do that by proving the triangle is congruent and then CPCTCing it. Okay, so let's go ahead and write this proof out. So I got step 1, I got the altitude. Step 2, let's go to perpendicular. We've been doing perpendicular up till now, so let's say that AT is perpendicular to MN. I could say if an altitude, then it gives you perpendicular lines. Step 2, I'm going to go ahead and say right angle. So angle ATM is congruent. Nope, sorry. And I need to say the right angles first. And angle ATN are right angles. And if perpendicular, then right. Now I'm going to prove the triangle is congruent, so I need those angles to be congruent to each other. So ATM is congruent to angle ATN. Right angles are congruent. Step 5. Now let's change the color here. Step 5. I need this one. Okay, and from that, I think we said that the angles are congruent. So angle MAT is congruent to angle NAT. That's going to be, if an angle bisector, it's going to divide an angle into 2 congruent angles. And now let's change color again. Going to have a reflexive, hopefully you can see that, down the middle. So 7 is going to be AT is congruent to itself. And now I can say that triangles are congruent. And that's of course going to be by angle side angle. Now I can say that MT is congruent to TN using CPC2C. And in step 10, now I can say that AT is a median. Okay, and that would be because of what we saw up above, 2 congruent segments. It's going to give you a median. Now we could have probably added a step here, right here, and said that T is a midpoint. That would be probably what we should have done. Okay, and that would be using definition of the midpoint, that's 9.5, and saying that if 2 congruent segments, that's a midpoint, and then what we would do here is say that this is a midpoint, and so it's a median. Okay, so you're looking at a 10, 11 step proof there. That is how these proofs do get a little bit tougher in this section. Okay, so let's try one more proof, maybe on the next page. Okay, we're going to look at this next proof here, proof number 5. I'm going to tell you right now, this is definitely on the harder side, so don't freak out if you struggle with this proof, but just try your best to follow along. There's a lot of given information, which does make this a lot more complicated, and so you have to kind of work forwards and backwards and kind of map this whole thing out and then go ahead and write the proof. So it starts out with saying this is congruent to this, and because of that, I know that by subsets congruent angles, I know that these two are congruent to each other. So just kind of keeping that in the back of your mind. I also know that this is a bisector and this is a bisector. Okay, which kind of leads me to believe that I'm doing something with multiplication or division property. So I just want to keep that in mind. And so if I have 2 bisectors here along with those blue angles congruent to each other, I know that all these little angles have to be congruent to each other. I also am given that this angle here is congruent to this angle here, and that this angle here now is congruent to this angle here. Now I know that this angle and this angle have to be congruent to each other. We had just mentioned that those angles are congruent by division property, right? We're going from bigger angles congruent to smaller angles congruent, so it's division property. And so therefore all these green angles are going to end up being congruent to each other by transitive property. And then it says that ds is congruent to HA, and I'm looking at overlapping segments there, which because it shares this middle segment right here, I can subtract that from both of them and know that, you know, DH must be congruent to SA by subtraction. And so a lot of this information, hopefully you can see, is leading me towards, and then part of what you have to do is kind of figure out, okay, which triangles are going to end up being congruent here. It's leading me towards those two triangles being congruent. Now you have to ask yourself, does that help? Well, if I'm looking for this to be proven, this side and this side, well, that's just going to be a CPCTC there. Okay, so hopefully you can see that it's a pretty complicated proof. Let's go ahead and write it out a little bit just to get some sense of how crazy this one gets. So let's start out with angle EHS congruent to angle LASH given. I know that I got some supplementary angles here. Angle EHS is sup to angle EHD, and angle LSH is sup to angle LSA. And because these are congruent to each other, okay, this is what, if straight angles, then sup. And because those two angles that I circled are congruent to each other, I know that these guys must be congruent to each other. So I'm going to write that in. So angle EHD is congruent to angle LSA because subs of congruent angles are congruent. Okay. Next thing is that I can do the green angles. So I know that this is true here in step 4, that's just given. And combining steps 3 and 4, I know that angle, I know these green angles right here, this one and this one must be congruent to each other by division property. So it's going to be angle CHD is congruent to angle RSA by the division property. And, okay. More angles to work with here, right? So now I can take these angles, let's stick with green here, these angles, that's given. And now I can say that all these angles are all congruent to each other. Okay, so which more importantly, I know that I need angle D to be congruent to angle A. Oops. Step 7. Angle D congruent to angle A. Transitive property. Almost there, almost there. Now I can go with DS congruent to HA. CS congruent to HA. Given. Step 9, I know that DH is now congruent to SA. And we said it was by subtraction property. And now I can say the triangles are congruent. So what's the name of the triangles there? It's going to be CHD and RSA. Triangle CHD congruent to triangle RSA by angle, side angle, 9, 7, and 5. And then one last step would just be that CD is congruent to RA by CPCTC. Okay, so a lot of the proofs in this section are going to end up being upwards of around 10, 11 steps, just like this one and just like the one we did earlier. Okay, so give them a try. Don't get intimidated by them. They're on the longer side, but hopefully you're getting better at these proofs and they won't be too bad. Okay, take care.